It's Tuesday, October 13, 2020. I'm Matt Miller at Trekzone HQ. Coming up today, NASA preps Osiris-REx to land on an asteroid, super habitable exoplanets postulated, and Dr. Brad and a team discover the closest star to be gobbled up by a black hole. Those stories, plus the headlines, coming up on this edition of Talkin Science.
Beaming around the world with the latest science and space news on Facebook Watch, YouTube, and wherever you get your podcasts. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
And it is a very happy Talkin Science Tuesday to Dr. Brad Tucker. Brad, welcome back for another week.
How's it going?
Really good. Daylight saving in full swing for Australia, and of course that means we go from 3 time zones to 672.
Yeah, it's amazing how it really works. It just dives into madness, utter madness.
And it's interesting you say utter madness because everyone has to think of the cows, especially in the 2 biggest states of WA and Queensland. Part of the reason that they don't join this daylight saving craze.
With our multiple time zones and multiple chaos.
But anyway, it is what it is, and from space, no one can see your daylight saving. I think that's an adaptation that I'm pretty proud of. And people can find you on social media at btucker22 on Twitter and Dr. Brad Tucker on Facebook. I'm on Twitter at Miramat86, and of course Trekzone all over social media. Brad, let's get the show started.
Talking Science headlines.
Any of the headlines this week? First up, China has selected 18 new astronauts in preparation for their space station launch.
That's right. They're gearing up for their launch of the space station, in a yearish time. And, just like every other space agency, will have astronauts up there doing experiments on rotations. And as you said, it's selected a 3rd group to go up to do those tasks. So, obviously a nice mark in their moving ahead plans for future space exploration.
Absolutely. Well, 17 men and 1 woman have been selected in this group, and they're falling into 3 categories. 7 aviators from the Air Force and will become the pilots, 7 engineers, and were researchers and technicians in aeronautics, astronautics, and other fields. And the last 4 mission payload specialists and were selected from applicants involved in space science and to China's piloted space program. Now, this is really cool. It's really a cross-section of the Chinese population to really represent them as they move forward with their space ambitions.
Yeah, both taking, pages out of other groups with obviously, needing pilots and the technicians on there, but obviously from the get-go trying to get lots of different people involved in their space program. Something that in the early days of the US and Russia, they just didn't do because it was all kind of one very particular group of people, and as the Roscosmos and NASA changed and evolved over time, starting to get a wider population and amount of people, and China kind of doing it from the get-go, which is kind of cool.
And also, too, I mean, we should recognise as well that there are concerns from countries around the world to China's space program, the speed at which they're doing stuff. From a purely scientific point of view, it's fantastic to have another player in the game to spread the knowledge and spread the understanding abilities around humanity. But we also should recognise the geopolitical climate as well, and with China striking out on their own, not necessarily for their own fault. I mean, they have been excluded from the International Space Station, so they're doing their own thing, but some people aren't too happy that they're doing their own thing.
Yeah, it's obviously challenging what other people are doing in terms of their ideas and views, but as you said, when you look at it, in the early days of the US and Russia, they went by themselves. They did their own thing. They were slightly cooperative, slightly uncooperative. And as you said, they can't even go to the International Space Station. So yeah, they have a very fast growing ambition and they want to do it. I think there's more cooperation than probably people imagine, and that will change. But to some degree, they need to do it themselves, both because they're forced into it and they kind of need to show they can get on par to do it themselves.
Well, speaking of the fast-growing ambition, Starman Elon Musk's Tesla just made its first Mars flyby.
That's right. That thing launched 8 months ago.
Yeah.
Has been out there in the solar system, flying around, doing whatever it does. It eventually, as you said, has finally reached its close point or close approach to Mars. After a long trip. I think it was something like 8 million kilometers away from the planet, which is relatively close.
It is absolutely incredible, and that's 0.05 astronomical units. Under 5 million miles. So really close, and well, it's closer than we are.
Yeah, exactly. Much closer than we are. And something like it would be, multiple times the distance the moon is away from the Earth. But it does a very long elliptical orbit. And I think one orbit around the 1 year of the Roadster, the car, is 557, something like that, Earth days. So a very long, weird elliptical orbit. And so it's kind of, that first close approach after it was launched such a long time ago.
And the whole reason for launching the Roadster into space and the Mannequin was to give a payload to the debut flight of the company's, of SpaceX's Falcon Heavy rocket.
That's exactly right. A necessary move to launch something. They couldn't just launch nothing, or they could have just launched complete rubbish, which some could argue launching a car into space was complete rubbish, but they needed something. They needed ballast essentially as that weight. So why not send your car with a dead body in the trunk?
Well, I mean, it's a perfect description of what it actually is.
Yeah, look, that's kind of what it is.
Well, the Falcon Heavy has gone on to launch two more times. Both of them have been operational, so it's fantastic to have the Heavy in service, and that goes towards the Artemis missions and the future of crewed spaceflight.
Exactly. So, definitely a step in the right direction.
Well, another step in the right direction for crewed spaceflight has to be my segways, which are fantastic, but also refrigeration. It's finally coming to space. There's a refrigerator installed on the space station.
Nicknamed the fridge. It's the first cooling unit ultimately in space for freezing refrigeration, which is a big step. And when we think about, well, why don't they have this earlier? One of the tricks is obviously refrigerators and cooling systems generate heat in space because of the microgravity. That heat doesn't rise. The heat flow in space moves very differently. So it's not like you can have an easy pump system that moves it out. It just kind of sits there. So it took a lot of fancy cooling system, essentially a water-cooled system, which we use in lots of other cases, to essentially heat the water, pump the heat out directly into a water cooling system to keep it cool and not radiate heat into the space station. So definitely a big step in terms of the technology for future spaceflight.
Now, just like the Strategic Homeland Intervention Enforcement and Logistics Division, aka SHIELD, in Marvel Universe, I'm pretty sure the researchers here had to come up with the right acronym just to spell out something really cool. And of course, in this case, it's the Freezer Refrigeration Incubator Device for Galley and Experimentation, also known as you said, the fridge. They could have just called it the fridge.
Exactly. Part of a good thing in astronomy and space is really contrived terrible acronyms to get your idea right.
And it is brilliant. I mean, you could say the long name, and if you really wanted to be a smartass up on the space station, if it does break down, you could use the full name, or you could just say the fridge.
Exactly. But look, it actually is an important thing. More than being able now to have real ice cream, they can store fresh vegetables, things that they actually grow in the space station. Probably more importantly is actually medicine. Lots of certain types of medicine need to be refrigerated, especially vaccines and virals. And you just kind of can't really do that in the current system. Makes it a lot better, a lot easier. And again, as more human space exploration, especially further away from the Earth, takes place, these sorts of things will be very critical critical to success.
Absolutely, and NASA is employing 8 of these units. The 2 are currently on their way, or I believe they're on the space station now, with 6 more to come, which are going to be used around the space station to chill temperature-sensitive test materials.
Yeah, that's right. I think they see a lot of promise, and plus this unit needs to be compact, like everything in space. So definitely a cool, exciting step in the right direction for future space exploration.
Talking Science, Stories of the Week.
Alrighty, Brad, our stories of the week kick off with Astronaut Bennu. NASA is getting ready to land on that little hunk of rock, but new studies have confirmed that it's a rich source of carbon.
Yes, one of the areas that have been wanting to explore is these certain types of asteroids, carbonous chondrites. And, we think these are kind of, for lack of a better way, loose piles of rubble. They're kind of bits of rock that have been stuck together, probably from a bigger collision or bigger asteroid in space that broke apart, or at least broke bits off. And yet it's a pristine clump of rock. So it's kind of the ingredients, the bits of space and the bits of stuff that was around the solar system, but still there in a way that's remained untouched. And you can kind of find out what the solar system was like, billions of years ago. And the fact that there's a lot of organic carbon on this is obviously exciting, because one of the goals here is to understand what ingredients, what things were around in the early part of the solar system, including what potential ingredients for life were around at the beginning of the solar system.
And the studies have been made by the Osiris-REx probe, which has been orbiting the little asteroid since 2018. It's a fast-spinning diamond-shaped rock. So now NASA is, as I said, gearing up to land on the surface and I guess take some samples.
That's right. So they're gearing up for a touchdown, 20 October U.S. time, so 21 October Australian time, where they'll go down. This tube will extend, reach the surface, and try and suck up as much rock as they can. And we're only talking about 50, 60 grams of stuff, and then it'll pop off the surface and eventually return to Utah in 2023. So very similar in a lot of ways to scientific goals of Hayabusa 2, a mission we talked about that the Japanese Space Agency led, and their exploration. And that mission, Hayabusa, will come back and land in Australia December 6th. So a very similar mission to Hayabusa 2, different asteroids, slightly different targets. And the reason you want to do these things is it's obviously great to do as much study as you can from orbit or from the ground, looking at these things in space. It's even better to get the stuff from that object, bring it back to Earth to do a lot more testing than what you can do on board a craft.
And it's going to land in a crater which has been recently weathered, making the perfect landing site. A little bit of shelter. The crater is called Nightingale Crater, which I think is a brilliant name, and hopefully it can live up to its namesake and protect the spacecraft as it lands.
Yes, and by also being recently weathered, you're kind of getting fresh ground. Space does weather things on the outside. So if you have something that's been weathered for billions of years, you may not get the right understanding of it. You may be seeing more the effects of space weather rather than the actual asteroid. So by seeing something that's a little bit more protected, a little bit more new, to get the insights that they would need. And again, this is something Hayabusa did, where they touched on the surface and also created a crater to see what was underneath. So definitely some exciting things in the future.
And there are challenges involved in not only landing on this asteroid that's fast moving and spinning around the solar system, but also once you're down successfully, the next challenge is to get through that rock with the probe and, as you say, suck up the dirt.
That's right. They actually have to get there. They actually have to do the landing and make it work. Which is no small feat, to be honest. But I think they'll do it. They'll be able to do it. And obviously one of the tricks with all this is once you do this maneuver, this touch and touch down and scoop maneuver, you can't be guaranteed how much stuff you actually collected. So if something goes wrong in that process, or you don't get as much stuff as you wanted, you don't really get an easy second shot. So definitely something that would be critical to watch to make sure they do it right and get it right and it all works right in the coming weekish.
And let's just touch on the significance of Bennu. It's very rare to find carbonite veins on an asteroid, so it's making it really intriguing. And I don't think this was actually known of this asteroid when the mission was launched.
No, that's right. This was something that was discovered on board the future study. Once they chose an asteroid A based on what they roughly thought it was, and also one they can get to in the right spots, both getting there and coming back. And then following up by studying in detail for about a year and a half from orbit properties of the asteroid, both to get an understanding of what they were going to go do and look at, but also the landing sites that they can choose to get the best bang for their buck. So definitely, part of the discovery process on way to going to the asteroid, besides just randomly sending a probe and hoping for the best.
Well, Brad, we're back on exoplanets for our next story this week. But more than that, looking at planets that are possibly more habitable than Earth for life.
That's right. So what we call, or what they're calling, super habitable planets. So these are places where, as you said, the potential for life may be better than here on Earth. So what they're saying is, let's look at the conditions needed for supporting life, and the most type of life. And again, this is not even just intelligent life. This is all types of life. Where could be the best spots in the solar system, and what conditions should those planets and really the planet star systems have to give you the best odds of allowing life to evolve or form, and therefore going to be able to find it. So this is in no way a means of saying there is life there, there will be life or is life or could be life, that these are just the conditions that give the best chance for life. So, stacking the odds in the favor, so to speak.
And it's a little bit of opening up the candidate pool, if you will, rather than sort of being so hyper-focused on mirror images of Earth, looking at other planets that can support life, a little bit like, science fiction shows talk about, and Star Trek in particular, with different classes of planets. And it's not just the Class M or the Earth-like worlds that can support life, but there are these other ones as well out there that can do pretty much the same job, maybe a little bit harsher or a little bit even better, as we're talking about here, than what Earth is doing. Just opening up that candidate pool.
That's right, because we know lots of different star systems, so the stars themselves are different than our sun, so that would change the temperature, the evolution, the age of the star and the planet. The planets themselves are different, so they could be bigger, they can be smaller. We know of a new type of planet, well, not a new, but it's a category of planet called super Earths. And these are Earths that are rocky planets that are bigger than their Earth, but still mostly rocky with an atmosphere, versus getting into the Neptune things, which become more ice giants and definitely a different set. And we know of lots of super Earths out there, so they're not quite exactly the same as Earth, but they could host it as well. And when you put that all together, what gives you the best odds in terms of finding potential life, as you said, opening that candidates or the potential gallery for where it could be. Because as we keep discovering more and more of these planets, which we will, being able to focus on which are the best ones for thinking and looking about life.
Now, this study was published by researchers at the Washington State University and published in the Journal of Astrobiology on Monday last week, just highlighting this research that's going on and looking at all of these exoplanets with all this data that TESS and its predecessor have looked at, and just all this information. We've talked about this in the past, about how there is so much data and information being gathered by all these telescopes that we have appearing at the sky, that we can just be analysing this data for the decades to come.
That's right, especially as we now move into studies of the star system itself, not just finding the planet, measuring the atmospheres of these planets as well. The rich information of all these things is just going to dramatically increase over the next decades. And more and more stuff's going to happen, more and more studies, more and more excitement will change, which is really cool. and a lot more stuff to get through, and for us to understand some of these big questions, which is what people want to do.
Now, having said we should be opening our eyes, if you will, and looking out for these super habitable planets, it's still pretty tricky to find exoplanets, and those methods that we've talked about in the past to find them. It doesn't suddenly become a brighter spot, or there aren't big neon arrows pointing saying, hey, here's a super habitable one. So it's still looking at all of these exoplanets and trying to find the ones that we could put onto a mission list.
That's exactly right. There's still a lot of work to be done. You still have to find it. You still have to understand it. And look, you still kind of want something relatively close. Of the 24 candidates that met this criteria in this study, and again, candidates being just ones that met the parameters, no idea of life, really, they're all still 100 plus light years away. So they're still pretty far away, up to thousands of light years. So it doesn't mean it's close. It doesn't mean it's going to happen anytime. So still a lot of work to be done, but obviously helping to refine the parameters for what we want. And, simple things that they pointed out, that slightly smaller stars will have a longer lifetime, which means the planet will have a longer lifetime, giving longer chance for life. All these little things which really add up into, I think, what they call a report card of, marks essentially of potential habitability, is really what the focus is on this decade, is understanding the planet star system, not just finding the planet. So you still have to find the planet, and then you have to study it. So a lot of work to be done.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
And last up this week, Brad, you're making some news. A team you're working with has discovered the closest star being devoured by a black hole.
That's right. Something we call a tidal disruption event, which is where you get a supermassive black hole and a star, in this case, the star system, I guess, but you wouldn't really see the planets, gets near the boundary of a black hole. The gravity of the black hole starts to rip it apart, and produces essentially a flare of a light, kind of spits some of these things out. So, it really starts to suck in the system, spaghettifies it and spits it out. And using both by telescopes in Australia and at the European Southern Observatory, followed up, which ended up being the closest one to date at a mere 215 million light years, just a skip and a stone away.
Brad, what does this discovery mean?
So look, one of the things that we're trying to understand is obviously what actually happens to these things when stars and things get too near the supermassive black hole. And we kind of know in theory, well, it gets too close, gravity pulls it, shreds the star, throws some stuff around it. By it being close, catching it as early as we did, and studying it as quickly as we did in as much detail, we're able to kind of see through the mess, because there's a whole bunch of dust and debris and a whole bunch of stuff just thrown around this area at pretty much super fast speeds. We're talking about tens of thousands of kilometers a second. So we were actually able to catch it, see through it, so kind of see the whole train wreck happening. So what happens not just at the moment the star gets close and starts to get to rip apart, but what happens in the following days to weeks as this stuff is shredded and thrown into space. So kind of putting together a fuller or more full picture of these massive, cool things in space.
And there's been a few discoveries of these TDEs, but this is the closest star that we've been able to observe being swallowed up, being gobbled up.
That's right. So this was the closest one so far. And, close just means ultimately easier to see, brighter, and follow up. And that's exactly what we did here. And we were able to kind of calculate that about the star was on order of about the same size of our sun. So, a not very big star. So, imagine our solar system, and about half the star was lost to the black hole. So about half of it got essentially ripped in half ultimately and fell in. So definitely able to pinpoint exactly how much of the star is ripped apart, in what ratios, how much goes into the black hole, how much is spewed into space, and all those sorts of things. So again, helping us to shed light on these kind of really massive events. And as we talked about a few times now, black holes are really changing, going from these fairly mysterious things we can't do a lot of to being able to see what they do, how they work, how they operate, the things they do on literally short timescales of days to weeks to months to years instead of billions of years.
And that's the really interesting thing, I think, with these black holes and the way that gravity works as well, is that when it gets to that critical moment, it's not going to take those billions of years. It might take the billions of years to get there and get to that point, but as soon as that point is reached, the point of no return, that's it. It's going to happen really quickly, and I think that's a really fascinating thing for me is that it's days to weeks, maybe months, for these events to happen when you're talking about galactic and universal scales.
Yeah, it's on a real time scale. It's a really relatively quick, short thing, and especially the peak of the activity, is obviously even shorter. And so, if you miss a lot of the main bright flash, you could miss it forever. And just like with exoplanets, we don't know where we're looking, we don't know what we're doing, we don't know where to find them. So, and you don't know which interesting explosion is going to happen in space, because the supermassive black hole in this galaxy, it was just a fairly generic run-of-the-mill galaxy no one really paid much attention to until this happened.
Is that a bit of a spinning the telescope and just sort of, just spinning in your chair and just go, oh, look at that tonight, and oh, wow.
Well, one of the benefits we have nowadays is we have telescopes that just kind of survey as much sky as they can, looking unambiguously. So it's finding the needles in the haystack. So it's finding the things that are normal, things that we kind of understand, the things close, the things by, the junk. So there's a lot of work in pouring through all of this data, which kind of with exoplanets are just coming in by huge volumes, finding the right ones and then following up on the right ones. So, my student, Harry Abbott, whose PhD project is to kind of find and classify these weirdo explosions as early as possible, took the first classification or study once this object was discovered on our telescopes at Siding Spring, and then realized that it was quite peculiar. But you have to choose the right one, and if you just ordered the list wrong, you may not get it as early, and you may not realize it's as interesting. So it's definitely a matter of a bit of luck, a lot of work, and with exoplanets, something still even the public can help us in terms of searching through the data to find the special rare ones.
Now, I have to ask, if as a student working on a PhD with a great discovery like this, what's next in the career?
Well, look, there's lots more to study, and what Harry's trying to do is link these sorts of weirdo explosions with the TESS telescope. So the TESS telescope, which we were just talking about, which helps find exoplanets, well, it also monitors, just changes the light of anything. So this includes supernova and explosions. So what better way than to see the explosion changing on the order of every 30 minutes? And that's kind of what he's combining now, finding these things early and getting data to follow it every 30 minutes. We actually were hoping that this was in the TESS field of view, but alas, it wasn't.
And I guess that's another thing as well, is that the way that, or the time that it takes to make these discoveries could be with him for much of his career as well.
That's right. This thing was detected in, I think, May of 2019. And it takes a while after following up for months and then to analyze it to actually get to results. So lots of things that have to be in the pipeline.
Fantastic, Brad. Well, that is a very cool discovery. Congratulations to Harry as well. And as we learn more about this black hole and black holes in general as well, I think it's really awesome and really cool. And we've seen real images of black holes, and now we're making these extra discoveries of them and really shining some light on what would have otherwise been a very dark hole in space.
Exactly.
Fantastic, Brad. Well, like I say every week, it's fun to pick apart the stories of the week with you, and looking forward to doing it again next Tuesday.
Thanks. Take care.